Okay, so in this video, I'm going to show how to do the calculation of molar mass and formula mass. This is section 4.2, the chemical formula, formula mass, and molar mass. Okay, so read over section 4.2 and take a look at these problems here, and then you can do the end of chapter problems. So a formula in the chemical term is a way of representing the number of atoms of all the different elements that are in a substance. So for example, if I have water, water is composed of hydrogen atoms and oxygen atoms that are bonded to each other. There's chemical bonding that goes on. We looked at that in the earlier chapter, right? Covalent bonding, we call that. So if we take, for example, water, instead of calling it water, we'll call it H2O. And the meaning of that is that there's an oxygen atom bonded to two hydrogen atoms, right? So here's a hydrogen, here's another hydrogen, here's an oxygen. Each of those atoms has a mass. So what we do to find the total mass of water, of one molecule of water, is we add up the atomic masses in the periodic table. And so just like with atomic mass, there's kind of two calculations we do: the mass of one molecule and then the mass of a mole of that substance. Okay, remember, a mole is like a handful. You have a lot of them. So how much does a handful of water weigh? That's going to be in the units of grams per mole. How much does one molecule, one little molecule weigh? That's going to be in atomic mass units, or AMU. The actual calculation of molar mass and formula mass is identical. It's just the units are different. Okay, so here's what you do. You look up in the periodic table these atomic masses. I'm going to do the formula mass first. It's essentially saying how much does the formula weigh. Okay, well, we have two hydrogens. That's what the meaning of the subscript is, 2. So we have two hydrogens, and each one has an atomic mass of 1.01 AMU. We also have one oxygen. If there's no number written as a subscript, that just means there's a 1. So it's 1 times 16 AMU. Okay, the 16 is down here, right? That's right there. So the units are AMU, and you would get 18.02. That's one molecule of water. Has a formula mass of 18.02 AMU, atomic mass units. And AMU is a very small mass. It's like 10 to the minus 24 grams. Okay. Now, the molar mass is the same calculation, but it's for a large number of molecules. So not just one molecule, but an entire mole of waters, okay? That's going to be a lot more, so we use a different unit. We just call it grams, okay? So the number's the same. You're just going to take your two hydrogens. So here's your formula. So 2 times 1.01, but now it's grams per mole. And one oxygen, 16 grams per mole. And you're going to get the same number you will for formula mass. It's just going to be grams per mole, right? So that means 1 mole of water weighs 18.02 grams. 1 molecule of water weighs 18.02 AMU. And again, the mole is such a large number. You got your little, here we go, coffee cup right here, right? You got this coffee cup here. There's a lot of water in there. Maybe there's, like, if it weighed 18 grams, it would be a mole. Now, actually, this is a lot more than 18 grams. 18 grams of water is about that much right there, just a little handful of water. Okay, that's a mole. Do the same thing for the second one, example 4.8. Calculate the formula mass and molar mass of calcium phosphate. The tricky thing here is this calcium phosphate. I've written the 3 elements down there. If you recall, calcium is in the second group. So that means it has a charge of +2. We did that with the naming in chapter 3. Phosphorus and oxygen together form a polyatomic ion called phosphate, right? Okay, so calcium is +2, phosphates -3. So we can do that thing. I talked a little bit about it when we were naming compounds, and that is the crisscross method. That if you have different numbers in the charges, you just switch them. So the 3 goes down here and the 2 goes down there. So you get calcium 3 and then phosphate 2. But we also said that if it's a polyatomic ion and you have more than one of them, you got to use parentheses to indicate that there's more than one of them. So 3 calciums, 2 phosphates. Okay, so I'm going to add up all the atoms. If you look at it, I'll come up over here. You really have 3 calciums. So that's 3 times 40.08. Let's again do the formula mass first. But now if you take a look here, there's a phosphorus here, that's 1, but there's 2 phosphates. So that's 2 phosphoruses, 2 times 1. So 2 times 30.97. See where I'm getting the AMUs? The atomic masses has come from the periodic table, the number underneath the symbol of the element or the name of the element. And then you've actually got 8 oxygens here because you have 4, but there's 2 of them. So that's 8 oxygens. 8 times 16.00 AMU. Okay. So let's take a look then. If we have all of these atoms together, I'm just going to add them to get the formula mass. So that would be 3 times 40.08 2 times 30.97, 8 times 16. It looks like it's about 310.18 AMU. That's how much 1 molecule of calcium phosphate would weigh. It turns out ionic compounds don't actually form molecules. They form these, highly interconnected, like stacks of oranges, right? Like salts, they form these solids. There's a lot of them all kind of packed on each other. But there's 3 calciums for every 2 phosphates in that formula. So the formula mass, how much that Ca3PO42 weighs, is about 310 AMU. The molar mass, we already did the work for that. Because remember what I said in the previous problem, the molar mass is the same number. You don't change the number. It's calculated the same way. The difference is instead of 1 formula or 1 molecule, if you want to think of it this way, remember this is for 1 molecule. This is for a mole. 6 times 10 to the 23rd molecules. Okay, so that's going to weigh a lot more, right? If I have 1 and it weighs 310, a lot's going to weigh a lot more. So why is it the same number? Different units. Remember, if I said 300 grams and then I said 300 tons, even though the number is the same, they're not the same amount, right? A ton is a lot of grams. So 310 AMU is how much 1 molecule weighs. 310 grams is how much a huge number of these molecules weigh. Okay, and we call that the molar mass. It's grams per mole. Okay, so practice these again. Feel free to watch the videos more than once. Practice them. Make sure you get the same number using your calculator, right? And then go back to the end of the chapter and do some of the problems on these. If you find you've got it down, and many people figure this out, how to do this well after just doing like 2 or 3, that's fine. And you don't need to do all of the end of chapter problems, but do them until you feel like you're pretty confident you know how to do these. Take care.